In today's video, here is a nice problem of Norway Mathematical Olympiad edition 1994. Here is the following statement. It says find all primes p, q, r as a prime numbers and natural numbers and satisfied this following equation. Okay, we have the reciprocal of this p as a prime plus the reciprocal of q plus the reciprocal of r equals the reciprocal of n as a natural number. Okay, we have three independent primes associated with a natural number n. It seems hard to solve this equation because we have four unknown variables here, but in reality it's not hard because we are going to go through many steps. Those steps can help us to solve this equation, because the nice thing here, we have the primes, because the prime numbers has only two options. It could be even, it could be odd. So I'm going to check when we have even prime and when we have odd prime. So you guys, you can give the hints to this problem prior to the solution. Go ahead, pause this video when you come back to see the full solution. Okay, now let's jump into the solution. Let's suppose if you have all the primes are even. Okay, let's suppose p equals q equals r equals 2 as an even primes. Okay, so I'm going to insert this one into the equation. I get here 1, I get half plus half plus half equals 1 over n. This one is clearly giving us 3 over 2 equals 1 over n. I'm going to take the reciprocal of that. Is giving us n equals 2 over 3. 2 over 3 is not natural number, which is, it clearly is a contradiction. It's impossible. Okay, I'm putting this sign, that's mean it's a contradiction. Okay, so let's go through the other case. All of them are even, it's impossible. You may have two even primes, the other one is odd. Let's consider r equals q equals 2 as an even primes, but p is an odd. Okay, plug in this one into the equation. I get half plus 1 over p equals 1 over n. This one is clearly is giving us number 1 here. So I get here 1 over p equals 1 over n minus number 1. Okay, since we have n as a natural number, so which means n is always strictly superior than 0. Okay, if this one is strictly superior than 0, minus number 1, which means this one is always negative. Okay, because this minus 1 is always bigger than this one. Since this one is negative, which it's clearly is a contradiction. It's impossible, I mean. Since both primes are not even, which means at least one is even, two are odd. So let's suppose r equals 2 as an even, but p and q are odd. Okay, so inserting this one into the original equation to see what's given us. I will have half plus 1 over p plus 1 over q equals 1 over n. Then moving over this half to the right, I get here 1 over p plus 1 over q equals 1 over n minus 1 over 2. So by moving over this half to the right, I get here minus 1 over 2. I'm going to take off this one. Now I'm going to take three cases. If n equals 1, p plus q over pq equals 1 minus half, which is half. Okay, 2 times p plus q equals pq. Okay, so as you know, this product is odd because they are both odd prime, so which means odd is multiplied by odd is given as odd, but the left hand side of this equation is even, which is it's clearly it's a contradiction. Okay, so let's take another case. If n equals 2, if n equals 2, which means I get p plus q over pq equals half minus half, which is 0. It's clearly it's a contradiction, which means the sum of these primes is 0, which is impossible. Okay, let's move on to the other case. If n is strictly superior than 2, if n is strictly superior than 2, okay, then the number, this one, becomes smaller than this one, because as n growing up more than 2, the denominator become bigger, but the reciprocal becomes smaller. It will be this one will be smaller than this half, which means it's clearly is negative. If n strictly superior than 2, this one is telling us p plus q over product pq equals 1 over n minus half is strictly inferior than 0, because it's negative. Okay, which also it's clearly it's a contradiction. What we have contradicted? We have contradicted r equals 2 is even, it's impossible, which means all these primes are odd. Okay, so this one is telling us r, p and q are odd. Now I'm going to clean up this board and move on to discuss when we have the primes are odd. Previously we have studied the status of these primes. We found all of these primes are odd. Now, without loss of generality, we assume r is inferior equal to q and q is inferior to p. Okay, now we will have the comparison on odd primes. We will have the comparison on even primes. Before, we found none of those works, but this one we are going to discuss the status of this one now. So first of all, we are going to check when we have the equality, when we have the odd primes are equal to each other. Okay, suppose r equals q equals p, okay, as a odd primes. Okay, I'm simply going to insert one of the primes into this one, the whole equation in terms of r, which means I will have 1 over r plus 1 over r plus 1 over r equals 1 over n. Equivalent, I get 3 times over r equals 1 over n. Okay, I'm simply going to take the reciprocal of this one. I will have here r over 3 equals n. So what do we know about this one? We know only n, since n is a natural number, which means r over 3 need to be a natural number too. Okay, but since r is a prime, must be equals to 3. R equals to 3 because r is a prime. If r equals to 3, which means 3 over 3 equals 1, which means n equals 1. If n equals 1 and r equals 3, which means all primes are equal to 3. So we'll have one of the first pair of the solution. I will have r equals 3, q equals 3, and p equals 3, n equals 1. I found first pair of the solution. Let's move on to another case. If we have r equals q but is not equal to p, okay, which means if r equals q is strictly inferior than p, we can have this case too. Okay, so I'm simply going to insert this one. I'm simply going to insert this equality into this equation in terms of p to see what's given us. Okay, so this one is telling us 1 over p plus 1 over r, which equals 1 over n. This one is giving us 1 over p plus 2 over r equals 1 over n. Okay, I'm going to move over the reciprocal of p to the right. I will have the following equation: 2 over r equals 1 over n minus 1 over p. By making np as a common denominator, I get np here, I get p minus n. Okay, I'm going to take the reciprocal of this one. I get here r over 2 equals np over p minus n. By multiplying both sides by number 2, I get here number 2. Since r is a natural number, also is a prime, okay? Which means the right hand side of this equation must be a natural number too, okay? Because the left hand side is a natural number. In addition, r is a prime, but is odd prime. But the right hand side of this equation is even, which it's clearly it's a contradiction. What we have contradicted? We have contradicted this one. R not equal to Q, which means we must keep strict inequality. Now we are going to discuss our problem on this interval. I'm going to move on to the general case, okay? Now let's go back to the original equation. So we have 1 over P plus 1 over Q plus 1 over R equals 1 over N, okay? By moving over these two terms to the right and leave 1 over R to the left, I get 1 over R. I'm going to do this one in elegant way. So 1 over R equals 1 over N minus 1 over P plus 1 over Q, like this. Then by making the common denominator here, I get here 1 over R equals 1 over N minus P plus Q over PQ. Then by making the common denominator here, I get here PQ minus N is multiplied by P plus Q is divided by N PQ, like this, okay? I'm going to take the reciprocal of this one. I get here R equals N is multiplied by PQ is divided by PQ minus N is multiplied by P plus Q. I'm going to take the same equality. I'm going to divide both numerator and denominator by PQ. I'm going to keep the same equality here, and I will have N divided by number 1 minus N is multiplied by P plus Q over PQ, okay? As we know, P plus Q is strictly inferior than PQ. Pick up any prime numbers, always you have the sum is strictly inferior than product. Then I'm going to divide both sides by PQ, like this. I get number 1 here. This quotient is strictly inferior than number 1. Then I'm going to multiply both sides by N. I get N here, okay? Then I'm going to multiply both sides by minus sign. By leaving the equality as the same direction, I just moving on these terms to the left and move this one to the right with minus sign. I get here minus N is strictly inferior than minus N is multiplied by P plus Q over PQ, like this. Then adding number 1 on both sides. Then take the reciprocal of this one. If I'm going to take the reciprocal of this one, I will have here, we'll have the whole denominator is strictly inferior than this one. So which means in the other word, I get this one is strictly inferior than N over 1 minus N, like this. Then I'm going to take the minus signs to the numerator. I'll get here minus N over N minus 1, like this. As we know, R, this is R, 0 is strictly inferior than R as a prime. Since we have N is strictly superior than number 1, okay? Because this one, when we have N is strictly superior than 1, because if N equals 1, you would have this solution as we have here, okay? Then this one is on this interval. Also, we have N minus 1 in denominator. We must keep N minus 1 strictly superior than 0. In the other word, N strictly superior than 1, okay? So this one, since N is a natural number, this one is a positive, which means the whole thing is strictly inferior than 0. In the other word, this one is taken as 0 is strictly inferior than R, R is strictly inferior than 0, which is strictly is a contradiction, okay, like this. We have proven we have no odd primes above N strictly superior than number 1, okay? The only solution that we found when we have N equals 1 it gives us the equality, which is r equals q equals p equals 3 as at prime. So I have ended with this video. If you have any question regarding this problem, just put it in the comment section below. Don't forget to support us with a like and subscribe. Thank you for watching. I will see you in next video. Bye.